Hi everyone. Notes 4.6 are on the volume of pyramids, cones, and spheres. And the first thing I want to talk about is the difference between a pyramid and a rectangular prism. So pyramid still has that square base. And you can see that base in this picture right here, but then it comes up to a point. Whereas if you were to look at a prism instead, the prism has two bases and they are parallel to each other. So it doesn't come up to a point like a pyramid does. And that point is called a vertex right here. While a prism's base is on the top and the bottom and they are parallel to each other. Okay, and the same thing is true about the difference between a cylinder and a cone. So if you look at this cone right here, same thing, it still has a circular base like a cylinder does, but it reaches a vertex, it reaches a certain point, versus a cylinder, and sorry about my terrible drawing, but you've got the idea, versus a cylinder where the base is on the top and the bottom, and again, they are parallel to each other. And same thing with a cylinder, the base is on the top and the bottom and they're parallel to each other, okay, versus a cone that reaches a vertex. It's pretty much the same idea. Now, if you remember in class, we talked about the fact that 3 square-based pyramids would make a cube. And that is why the volume of a square-based pyramid is the area of the base times the height, but divide that by 3 because the formula for the volume of a rectangular prism is the area of the base times the height. So here we would divide by 3 because 3 of these pyramids would fit into a rectangular prism with the exact same base. Okay, so here we're going to say the volume is equal to the area of the base times the height divided by 3. And just a quick note that the capital B here means the area of the base. So let's go ahead and figure that out. So it says to determine the volume if it has a height of 200 meters and a base length of 60 meters. So to find the area of the base here, our base is a square. It's literally called a square-based pyramid. So if this is 60, then this is also 60. So to find the area, we would do 60 times 60, which is 3,600. Or we could also just do 60 squared, which would still give us 3,600. Okay, amazing. So now here, this volume is going to be equal to that 3,600 multiplied by this height, which is 200 meters, and then in the end, we're going to divide by 3. So let's go ahead and do this. So the volume here would be equal to our base area, which is 3,600, multiply that by the height, which is 200, and then I'm going to divide that by 3. So here, let's just go ahead and evaluate. So 3,600 times 200, when I multiply those two guys together, I end up getting 720,000, and then I still have to divide that by 3. And then when I divide that by 3, I get my final answer, which is 240,000 meters cubed, because this is a 3-dimensional figure. So we have cubic units as our answer. All right, in our next example, we want to find the volume of a cone if it has a height of 10 meters. So here we'll label this as a height of 10 meters and a diameter of 4 centimeters. So here we know from here to here, it has a diameter of 4 centimeters. So that means that our radius would have to be 2 centimeters because our radius is always half of this diameter. So we know we can label this here as 2 centimeters. Now, just like the square-based pyramid compared to the rectangular prism, the cone, the volume of a cone is always going to be 3 times smaller than a cylinder because you need 3 cones to make a cylinder. So all we have to do is take the volume of a cylinder, which is the area of the base, times the height, and then just divide that by 3. And to find the area of the base, we always have to find the area of a circle, which is pi r squared, and then we would multiply this by the height and then divide by 3. So let's go ahead and do that. And just a reminder, B represents the base area, not just the base. And in this example, the base is in the shape of a circle. So the area of a circle is pi r squared. And we know that our radius is 2. So I'm going to say b equals pi times 2 squared. Again, that's because we know our radius is 2. Well, 2 squared is 4, so I end up getting 4 pi. And I'm going to leave this as 4 pi for right now because this is not my final answer. So I'm going to use that information here to find the volume. So if it's base area times height divided by 3, and I know that the base area right here is equal to 4 pi, so I will fill in 4 pi here, and then I'm going to multiply that by the height, which we know is 10 centimeters, and then I'm going to divide that answer by 3. Well, to figure this out, I would multiply 4 pi by 10. So 4 times 10 is 40, so I end up getting 40 pi. I'm going to divide that by 3, and then I can just type that whole thing into my calculator. So let's go ahead and do that and see what we get. We'll round to the nearest whole number in this example. So I'm just going to type in 40 times pi. Make sure you use the pi key and not 3.14. Then I'm going to take that answer and divide that by 3. And I end up getting 42 when I round this to the nearest whole number. Or if you want the whole fraction to begin with, you just press the divide sign. And then I have my fraction. So I can literally type in 40 pi over 3. And I end up getting 42. All right, in our next example, we're still going to do a cone. So it's still going to be the volume is base area times height divided by 3. And the first thing we have to do is find the base area. And to find the base area, we use the area of a circle because the base is a circle. So here it tells us that it has a height of 32 centimeters, so I'll label that in. And then it tells us that it has a slant height of 40 centimeters. Well, I don't know the radius. The radius is unknown. So the first thing I have to do is find the radius. So here I'm going to label the radius here as r. And if you notice here, I end up getting a right triangle here. Right? Do you see this right triangle here? So since we have a right triangle in our cone, we can use Pythagorean theorem to find the radius. So let's go ahead and do that. First thing I'm always going to do is look for my right angle and use that to identify the C value. So my C value is 40, which means that A is 32 and B is R, or I could swap A and B, it doesn't matter. So when I do A squared plus B squared equals C squared, I'm going to replace this A with 32. I still have to square it. I have to copy down the plus sign, and let's color code this so you can see this here. So that's why I replaced the A with 32. Copy down the plus sign. We know that the B is the R, so I'm just going to write down R right here. And I still have to square it, and let's keep the R red so we can be consistent, equals, and then here I have the C value, which we know is 40. So here for C, I'm going to replace it with 40. But again, I still have to square that 40. So we need to figure out, well, what's 32 when I square it and what's 40 when I square it? So let's type those into our calculator and see what we get. So 32 squared is equal to 1024 and 40 squared is equal to 1600. So here, this turns into 1024. I copy down this plus sign, I bring it down. I copy down the r squared because there's nothing that I can do with that. And I write down what 40 squared is, which I know is 1600. Well, my goal is to get that r squared alone. So I need to get rid of this 1024 because it's on the same side. And since this is addition, I'm going to subtract 1024 from both sides. This goes away on the left side. I don't have to write 0 down. I just bring down the r squared, and I know that r squared is going to equal to whatever 1600 minus 1024 is, which is 576. Now to get this r alone, I have to square root both sides. And the square root of 576 is 24. Let's double check. Yep, it sure is 24, so we're good to go here. So now I can use this radius of 24 in for r right here. So I'm going to find the base area now. So the base area is going to be pi times 24 squared, because this is no longer a mystery. I know it's 24. And when I do 24 squared, I end up getting 576, which we already knew from here. So I get 576 pi. All right, now we have enough information to find our volume. So the volume is going to be equal to the base area of 576 pi, and I'm leaving it in terms of pi for right now because I don't want to deal with decimals. So I'm going to write 576 pi, and then I'm going to multiply that by the height, which I know is 32. Now we have to use the height and not the slant height, so do not use this 40 right here to figure this out. We only use the 40 to figure out the radius by doing Pythagorean theorem. Once we do that, we're done with the 40. And then I'm going to divide that by 3. Now I can just multiply these numbers together and then divide by 3 straight into my calculator, and I will get my answer. We'll round to the nearest tenth this time since it doesn't tell us what to do. So just make sure though that when you do this, you use the fraction key, which is the division sign. That'll help you get the right answer. So watch this. I'm just going to use the division sign, and then I'm going to type in 576 pi multiplied by the height of 32, and then just divide that by 3, and I get 19,301.9. I said I'm going to round to the nearest tenth, and because the 9 has a 4 after it, that 9 stays a 9. And this is centimeters cubed. All right, last one we have is a sphere, and we want to determine the volume of a sphere if it has a radius of 3 meters. So let's look at the formula for the volume of a sphere, and we know it's 4 pi r cubed divided by 3. So let's go ahead and write that down. Here it tells us that the radius is equal to 3. So here I'm going to replace this r with 3. So I end up getting v equals 4 pi times 3, and then I'm going to raise that to the power of 3 all over 3. Well, the next thing I need to do is determine what 3 to the third power is. And just a reminder, 3 to the third power does not mean 3 times 3. It means 3 times 3 times 3. It means multiply 3 by itself 3 times. So 3 times 3 is 9, and then 9 times 3 is 27. So here I'm going to replace this 3 to the third power right here, 3 to the power of 3, with 27, and then I'm going to divide that by 3. Now, take a look at this on our calculator. Here I'm going to do 3 to the third power. So if I do 3 and then I use the power key on Desmos, which is nice right here, it's the a to the b power button right here. 3 to the third power tells me it is 27. Now I need to multiply this 4 by this 27, and when I multiply 4 by 27, I end up getting 108. So I end up getting 108 pi, and then I want to divide that by 3. So I'm just going to type that whole thing into my calculator, and this time I will round to the nearest whole number. So just a reminder, you have to click on the divide sign to get that fraction. So 108 times pi, and then divide that number by 3, and I end up getting 113, rounded to the nearest whole number. So here my volume would be equal to 113 meters cubed. And that's it for this video. If you have any questions, let me know. Otherwise, I will see you in class. Bye.